Hi, welcome to my channel EasyML. In this video, we will see how we can evaluate principal component analysis. When we are evaluating PCA, we need to check for two things. First, whether or not the principal components are capturing the essence of the original variables. The method to evaluate that is by looking at something called the loading matrix. Second is to check whether the principal components are independent. For that, we can simply take a look at the correlation matrix. Let us now see how the principal components capture the essence of the variables. On the left here, I have the loading matrix. The loading matrix helps us evaluate how the variables are literally loaded into each of these principal components. Recall, in the previous video, we saw how a portion of height, weight, and age is loaded into three principal components, that is PC1, PC2, and PC3. In this loading matrix, we can check how the original variables, that is height, weight, and age, are correlated with the new variables, that is the principal components PC1, PC2, and PC3. Again, if you can recall that any correlation that is greater than 0.3 and less than minus 0.3 is deemed to be significant. Here, we can see that the first principal component, that is PC1, has a correlation of 0.6 with the variable height. Since this correlation is greater than 0.3, we deem it to be significant. Next, we can see that PC1 has a correlation of minus 0.76 with the variable weight. Since this is less than minus 0.3, we again deem this correlation to also be significant. Now, we can again see that PC1 has a correlation of minus 0.54 with the variable age. Since this is again less than minus 0.3, we say that this correlation is also significant. We can now safely conclude that PC1 is strongly correlated with all these three variables. Since it has a strong correlation with all the three variables, we can confidently say that PC1 captures the essence of all these three variables. So instead of using three dimensions, that is height, weight, and age, I can choose to just use one dimension, that is PC1. Now, let us take a look at the second and third principal components. If you can observe carefully, PC2 has a significant correlation with weight and age. So we can say that PC2 captures the essence of 2 out of 3 variables. And the last principal component, that is PC3, if you can observe carefully, has no significant correlation with height, weight, or age. Conclusively, as long as any one of the principal components capture the essence of all the variables, it is okay. So in the next video, we will look at how we can further evaluate principal component analysis. Thank you and stay tuned.